Okay, I'm just going to walk you through those practice problems, the practice FRQs for the final exam. I just want to walk you through those, how to get those answers. So let me see, what did I do? The first one said the grasslands have a productivity of 312,000 calories per acre. Calories per acre per day. Now, it didn't say on there, but it would have been better if it had said whether that was gross productivity or net productivity. But we're going to assume that that was gross primary productivity, GPP. Okay? In other words, productivity is what the producers make. Productivity is the energy captured by the producers. That's the gross productivity. It's the total energy that they capture. Gross primary productivity. I don't really like to use the word primary because if it's a producer, it's primary. So I usually just say gross productivity. At any rate, if they catch this much per day, if they trap that much energy per acre per day, how much energy do carnivores get in a month is the question. So I'm going to have to change this into months. I'm going to have to change this from producers to carnivores, right? So I'm going to just start with this part right here using the 10% rule. Here's my 312,000 calories. That's in the producers. Then it's going to go to the herbivores using the 10% rule. I just moved the decimal over. I have 31,000 for herbivores. And one more time for the carnivores, 3,120 calories for carnivores. Nice, there's my answer, huh? Yes, if the question asks you the amount per day, because this was per day, but it wanted the amount per month. So I have to multiply that by 30 to get my final answer. So let me see. Calculator. Clear it. 3120 times 30 equals, here's my actual final answer, 93,600 calories per month goes to the carnivores. Okay? That's the first question. Then there was another question about that, about how many herbivores can live in an acre. Now that one gets much trickier. So I'm going to keep this in mind. I'm going to need this. Now I like to do these with the dimensional analysis. That's what I'm thinking of. And I always start by thinking about my final answer should be in what unit. Okay, it should be herbivores per acre should be my final unit, right? So, I've got calories per acre, right? And I want acres on the bottom, so that's where I'm going to start. I have 1 acre gets 312,000 calories. But I want herbivores, so I have to move the decimal over one place. 31,200 calories for 1 acre. I actually left out part of the problem. We have to know how much energy an herbivore needs to survive, right? So let's say that an herbivore needs, oh, let's say it's a big one like a bison in the grasslands, a buffalo. Let's say that it needs, I don't know, maybe it needs 12,000 calories a day. Okay, so if it needs 12,000 calories a day, and all I have to do is cancel out my calories, right? I don't want calories in my final answer. So this 12,000 is going to go at the bottom so that I can cancel the calories. And this is in one day. Now, what if I change this and made this be in a week? Let's see, what's 12 times 7? Isn't that what, 84? So this is going to be for a week now. 84 calories. It's set up the same way, but this is now for 1 week. Which means I have to have one more conversion in there because this was per day. This is per week. So I want to cancel out my weeks by putting this one at the bottom, which means I have to put 7 days up here. 7 days are 1 week, right? This is basically multiplying by 1, 7 days over 1 week. So here's my final answer. 31,200 times 7 equals, I'll put it down here, 218,400 over this 84,000. Equals 2.6 bison per acre for 1 week. Now ask yourself, does that make sense? Would there be enough grass for 2.5 bison to live in 1 acre for a week? It sounds like there might be to me. If you don't like the idea of thinking about 2.6 bison, then double it, and basically it's 5 bison in 2 acres. An acre is about the size of a football field if you want to try to visualize that. Okay? So that's how you would do those. Next question about population sizes. Let's see. Oh, what was my number for bison? They need 84 a week. Okay, the next question about population sizes, we're going to go to the savannah, and there's 5,000 giraffes. And if you remember, we used the letter N to represent the original population. Births would be 220 babies. Deaths would be 175. That's what I've given you. Remember to calculate population growth, R, the rate of population growth. It's B minus D over N. So we have 220 minus 175 divided by 5,000. So what do we get here? 220 minus 175 equals 45 divided by 5,000 equals 0.009. Now, if you want to think about this in a percent, you're going to have to move the decimal 2 places over, multiply by 100, which would be 0.9%, almost 1%, which is growth, because it's positive, it's not negative. We are seeing the population get bigger. There were more births than there were deaths, so we should get a positive number. It's not very fast growth, 1%, but it's definitely growing. So that's the first part of the question, is find the growth rate, 0.9%. Okay, I'm going to write that down up here, equals 0.9%. point, and we're going to want to use it in this form in a minute anyway in our calculator. So 0.009 is our growth rate, just below 1%. I'm still going to need the 5,000 giraffes. Now the question was, how many will there be in 5 years? And one way to do that is with that chart, and you're welcome to do that. Personally, I would prefer to use my calculator and this equation. This is the final answer. This is the initial number, which was 5,000. R was what we calculated right here. And T is the amount of time that's going to go by. So this would be raised to the 5th power. So what I'm going to do is, in my calculator, I'm going to put 1.009, right? Put this number in first, 1.009. Is it clear that this is just 1.009 once you do that addition? But I have to raise this to the 5th power. So you have to turn your phone sideways or find the X to the Y button. On some calculators, it's the Y to the X. I put in 1.009, Y to the X, then I just put 5, and then I just hit the equal sign. This is now 1.0458, and it keeps going. I'm just going to leave it on the calculator and multiply times 5,000. Equals 5,229.08, etc. Now, let's think about that. Here's my final answer. I'm saying after 5 years, there'll be 5,229 giraffes. Does it make sense? Am I happy with that? Well, it started with 5,000, and I noticed that it was growing slowly. There were 220 births and 175 deaths. So there were more births than deaths, so I should see the population go up, but not a whole lot. Is that what my answer did? I would agree. It went up a bit, but not a crazy amount. Okay? Enjoy. Oh, I hope you could see all that math I was writing down.